Hello students, today we're going to start something new and it's going to be a continuation of some geometry stuff, but it's going to be all about transformations, okay? Transformations we might know as translations, reflections, and rotations, or back in the olden days we learned them as slides, flips, and turns. But we're going to use the specific words translations, reflections, and rotations. Today we're going to start with 8.1, which is translations. Now, translation is sliding a figure to a new location, with emphasis on sliding, without changing the size or the orientation. The orientation is whether it turns or not, okay? So when we slide, when we do a translation, it doesn't turn, it just slides from one place to another. The new figure is congruent to the original figure, okay? So you can see an example that I have here. You do not have to draw this on your paper. We'll write down some things, but you don't have to graph it, okay? So we have a figure, and we have two figures. How do I tell which one is the original and which one is the new? Exactly, you're exactly right. You look for the prime. This does not have a prime on quadrilateral JOHN. How convenient. This has J prime, O prime, H prime, and N prime. So this must be our new or translated figure. Original, translation, okay? So we've got to figure out, how did I get from the original to the translation? So I want to pay specific attention to one set of points. We're going to start with the J's, okay? My original J is negative 10, 5. My new J is 1, 10. So how did I get there? So if the original J is negative 10, 5, and J prime is 1, 10, how did I get from here to here? How did I get from negative 10 to 1? You're probably thinking in your head, You're right, you added 11, okay? So I know that my x's are changing by adding 11. How did I get from 5 to 10? Well, I added 5. Well, we have this fancy thing called an algebraic representation, and you might remember this from dilations when we did an algebraic representation. The algebraic representation for translation is x comma y in parentheses. We always start with x comma y in an algebraic representation. And then we have an arrow, and now this is asking me, what am I going to do to that x and y to get to my new figure? Okay, so it's x plus a comma y plus b. Because I have to add something to x's to move left or right. I might be subtracting. I have to add something to y to move up or down. That's why we have adding to x and adding to y to see where we're going. Now again, it might be adding a negative number, or we might be subtracting, but subtracting is the same thing as addition, okay? So let's figure out. If I went from negative 10 to 1, then we said I added, so I'm going to start my algebraic representation with the x comma y, and so the x is, I added 11. With the y's, I went from 5 to 10, I added 5. So there's my algebraic representation. Let's see if it works for O and O prime. What is negative 7 plus 11? Positive 4. What is 6 plus 5? 11. So from negative 7 to 6 to 4 comma 11, I added 11 to the x's and 5 to the y's. It has to work for every point. And you'll see if you add all of these together, or you look at all of these and you apply the algebraic representation, then you'll see that it works for all of them. Okay? So one of the tricks in a translation is figuring what is the algebraic representation. What did I do to get from this figure to my new figure? I added x's to the 11s and 5 to the y's. Like I said, sometimes you subtract, we'll see one of those in a minute. For the next example we're going to look at, I'm not even going to draw any pictures because it's not really necessary. I'm given the coordinates for a triangle. Triangle D is at 4, 7, A is at 3, 2, and B is at 8, 5. Oh my gosh, that's triangle dab. Who knew? Now I've got to figure out what is the translation going to be? And where are the new points going to be after the translation? Well, I'm given this algebraic representation. And the algebraic representation says x comma y, arrow x minus 4 and y minus 7. What that means is for every x I have to subtract 4, and on every y I have to subtract 7 to end up with my new image. So we're going to see d prime. And with d prime, my x and y is 4 comma 7, so I have to do x minus 4. 4 minus 4 is 0, and 7 minus 7 is 0. So that is d prime. I took my x and y and applied the algebraic rule. So now I'm going to go to a prime. 3 minus 4 is negative 1. 2 minus 7 is negative 5. So I know that a prime is going to end up at negative 1 comma negative 5. And then we have b prime. 8 minus 4 is 4. And 5 minus 7 is negative 2. So that is where the new image is going to end up for d prime, a prime, and b prime, based on what they told me the translation was going to be. So to kind of just wrap this up a little bit, sometimes you're given two figures and you have to figure out what the algebraic representation is. Other times you're given an algebraic representation and you have to figure out where the translation is going to end up. So if you're able to do both of those, then you got this. And in honor of triangle dab and dab prime, we'll just do another one. So here are your two practice problems just to see what you've learned. Number 1, write the algebraic representation if r is 2 comma negative 3 and r prime is 0 comma 1. So you're thinking, how did I get from this x to the new x? How did I get from the original y to the new y? Write it out as an algebraic representation in the form parentheses x comma y, arrow, parentheses x plus something, y plus something. Could be minus as well. For practice problem number 2, you're given the algebraic representation. X comma y translates to x minus 3 comma y plus 4. And b is at 4 comma negative 2. What is the coordinate for b prime? So apply the algebraic representation to 4 comma negative 2, and then tell me what b prime is. Then take a picture of your practice problems and submit it through Edmodo. And just to see if you really watched to the very end of the video, if you write down this phrase on your practice problem, and it's in the picture when you submit it to Edmodo, I'm going to give you some bonus tickets, because this, people, is coming out in December.